with us today talking to us about mobile sensor and ecological momentary assessment data, representational and standardization challenges. Dr. Sim is a primary care physician, informatics researcher, and entrepreneur. She is a professor of medicine at the University of California, San Francisco, where she co-directs biomedical informatics at UCSF's Clinical and Translational Sciences Institute. Her research focus, background, can everybody mute their computers or phones? Thanks. Her research focus is on computational methods for data sharing and decision-making for clinical research and mobile health. She is co-founder of mHealth, a nonprofit organization that is breaking down barriers to mobile health app and data integration through an open software architecture. In addition, Dr. Sim is a consortium core lead for the Mobile Sensor Data to Knowledge NIH Center of Excellence. As Dr. Sim had shared with us, mobile sensors and apps go beyond what's traditionally captured in electronic health records. This talk today will be discussing the state of mobile health data and data standards, including open mHealth standards and how they complement other open standards like FHIR. This talk will also present mobile data to knowledge approach to sharing mobile sensor data and the BD2K Consortium. I want to thank Dr. Sim for her partnership in communicating this information to us today. Before I pass the control of the slides to Dr. Sim, who will begin today's talk, I want to remind you to put yourselves on mute to help avoid any background noises. And we would really like to hear from everyone, so if you can include your questions and comments until the end, where Dr. Sim will be able to answer them, that would be most appreciated. Please note that this session is being recorded and will be made available for future use on our landing page, bd2kbiostandards.org. At this point, I'm going to hand the control over to Dr. Sim. Thank you. Whoops, sorry, one moment. Okay.
Trying again. Okay. Hi, can everyone hear me?
Yes.
And can everyone see my introductory screen?
Yes.
Yes.
Okay, so thanks everyone, and thanks Rhonda for inviting me to give this talk. We have some time here to talk about mobile data. So first off, a definition of mobile health is using mobile apps, wearables, and sensors for preventive and for clinical care, and also for research. Some of you have probably seen Bruce Schatz's picture of the 5 rings of health, going from biology to body to stress, social networks, and societal conditions. And I would ask sort of as an exercise for the listener to come up with a condition that crosses all 5 of these. And probably all of you have, quite a number coming up in your head right now. A harder task actually to think of a condition that does not include all 5 of them. And I think that's just to show that many of the conditions that we're all interested in, are influenced by many levels, and that mobile devices, mobile data is in some ways uniquely capable of giving us an insight and some data into each of these 5 rings of health. So going a little bit deeper into that, just some of the sensors that are now available regarding physiology, for example, MC10 is a company that just announced their newest biostamp sensor recently, and it's a sensor, as you can see here, that tracks accelerometry, gyroscope, EMG, EEG, and it's a sensor that you can stick anywhere in on your body. So you can put one on your left leg, your right leg, on your trunk. MC10 is specifically targeting the research world. There are a number of the sensor companies that you might have thought of as being commercial sensor companies that are actually targeting the research space, which brings up, of course, the question of, the importance of data representation and data quality. Of course, the Google Lens, collecting your blood glucose from your peers. In the realm of behavior, emotion analytics, you've probably seen this, being able to analyze faces for emotions, work that we've done with Jim Ray and Greg Abowd from, who are part of our MD2K Center, using first-person vision, sort of like a Google Glass, to track behavior via eye gaze. And here is a application where a parent is wearing the first-person glasses as well as the child who is autistic, and that allows measurement of like eye contact, eye gaze. And you see the child having wrist sensors here, measuring things like repetitive motion, which is very common in autism. So again, try to get at measures that are clinically important that we haven't been able to get at before. Certainly social network data. Here's a study from 2013 or so looking at Twitter data and predicting depression with a 70% sensitivity and 90% specificity trained on 2.2 million tweets. There's a lot of thought work on tracking your digital exhaust, your use of your apps and so forth to infer your both your social status and perhaps your psychological status. The built environment, the Internet of Things, 25 billion things now, 75 billion by 2020. So there's a lot of data that's coming in, obviously, and the opportunity is to use the sensor data for new insights into many aspects of biology, behavior, and environment 24/7. Now, the challenge here is really to transform all this raw sensor data into meaningful and actionable digital biomarkers. It's what we hear a lot. Very exciting, but you know, this is just going to overwhelm me. I just need something that's meaningful and not just a whole, not a fire hose. So that is the challenge that is taken on by our BD2K Center. Santosh Kumar, our FHIR's leader from Memphis, and you can see the many institutions that are involved in this center on the bottom. The approach of BD2K to this large problem is to break it down into sensors to detect a phenomena that's interesting, to predict a phenomena that's clinically meaningful and valuable, and then to support intervention in a way that would improve health. So starting on the left here, to detect a meaningful digital biomarker, BD2K is working with a number of sensors. AutoSense, and I'll flip to the next slide here. AutoSense is a chest band that measures ECG and respiration, and also has a wrist accelerometer. And that one we're using to detect stress and smoking and conversation. The eyeglasses, as I mentioned with Jim Ray and Greg about from Georgia Tech, that is a camera that also assesses gaze. Are you seeing somebody smoking, for example? EasySense is a sensor which it's a contactless sensor that detects the motion of the heart, the lung motion, and also fluid levels in the lung. And wristwatches, both the commercial Microsoft Band and also sensors from BD2K labs detect eating, drinking, and smoking. So what we need is that these markers then need to be used to predict meaningful things. So we have two clinical projects that drive the work in BD2K. One is on smoking cessation and one is on congestive heart failure. So in the smoking cessation project, the hypothesis is that the marker of stress is a predictor of relapse of smoking. So these are people who have just quit smoking, and the hypothesis is if they're stressed, they're going to reach for that cigarette again. Okay. On the congestive heart failure project, that lung water detection of lung water congestion, pulmonary edema, would predict admission. And both of these obviously are outcomes that we care about clinically, and the patients care about too, which is probably the most important. And if we get these predictors, then we can then intervene. There's a whole platform within BD2K to support just-in-time adaptive interventions for smoking cessation. That if we notice that somebody is stressed, that we can then ping them and give them a stress reduction exercise, and that should, we hope, and we'll test that that would then reduce relapse of smoking. Similarly, for congestive heart failure, if we detect pulmonary edema, then we would notify the physician or the clinical team, increase the diuretic, and then hopefully close the loop and reduce admission. So, but it's a general process of detect, predict, intervene. The BD2K Center is developing sensors to detect these biomarkers, a computational platform for identifying the predictors, and then also an interventional, just-in-time interventional platform to take these predictors and then influence people in real time to improve health. So the sensors then include the AutoSense one, EasySense, some commercial sensors like Microsoft Band. We're working with the Omron scale and also the blood pressure. So a suite of sensors that we're using in MD2K. Also in MD2K, we are working with the Count Everything project. This is an administrative supplement through BD2K. It's a collaboration of MD2K, Harvard Picture, the UC Santa Cruz Center for Big Data in Translational Genomics, and the BioCaddy project at UC San Diego. And this Count Everything project is essentially a federated count where the objective is to be able to specify a query, or that in the background there, of patients who have a certain phenotype of mobile data, of EHR data, and of genomic data, and to be able to query across them in a secure environment, a secure fashion.
Can I just remind everybody to put yourselves on mute to avoid any background noise? Thank you.
Thank you. So summarizing the challenges, just as an introduction here, is that there are particular challenges for clinical care and research that involve representation, standardization, validation, and provenance. And then within the BD2K, challenges for data sharing, and then for federated data query across multiple data types. So I'll step through our approach to these problems and start off by grounding us in a clinical problem. So hypertension is a highly costly condition, highly morbid condition. We need a lot of different kinds of data to manage hypertension. Some of this data is objective data, like weight. Some of it is subjective, like chest pain. Some of this can be passively monitored, like physical activity. Some of it needs to be actively reported at this point, nutrition, for example, and medication adherence. And one of the things that we know in hypertension management is that we should have physical activity. That's good for lots of things, and many, many guidelines are consistent in saying that we should aim for 150 minutes per week of moderate intensity activity defined as 3 to 6 METs, which is a measure of oxygen consumption, essentially energy consumption. Now, in the commercial sensors, you know, there are a large number of physical activity sensors, and you would think that we should be able to use these sensors, collect this data, and use this clinically to meet a guideline, which, you know, we're confident will improve clinical outcome. So there's an opportunity sitting right there. And what's the reality? With all these sensors that are out there, the reality, of course, is that all of these sensors are built pretty much in silos, and the data is captured in a way that is very difficult to put together. So just stepping through as an example, Fitbit activity data reports the number of fairly active minutes. It's hard to know what fairly active really means. Certainly is an output as METs. So let's put that on a table here. Google represents activity data as a type of activity, a duration in milliseconds, and gives something called num segments, which I'm not quite sure what that is. The activity is an enumerated list. You can see here it includes aerobics, badminton, baseball, jogging, road biking. And one way to get to METs from this kind of information is to look at something like the 2011 Compendium of Physical Activities. And you would note that if you are bicycling for leisure, to work, or for pleasure, the estimate is about 4 METs. If you're racing but not drafting, it's 15.8, and certainly if you're unicycling, it's 5. So you would do this mapping, and then you would add up the minutes at, you know, at 3 to 6 METs. So that would be one way of going about it. HealthKit does give you a workout activity type. Of course, the list of activities is different from the list that Google Fit produces. HealthKit also gives start date, end date, from which you can calculate the time and the distance, and there you can use a number of equations to convert duration and distance to METs. You know, with Google Fit, there's also data that you can get that would allow you to get duration and distance as well. So it's a little bit more complicated than what I presented here, but in general, this is totally doable, but it seems to be more difficult than it needs to be. For many people who are out building apps and sensors for this particular purpose who don't have a clinical or a physiology background, this is more difficult than it needs to be. And we're not even getting into some of the more clinical data, stress, and more complex data like stress or lung water congestion that we see and that we expect to see more of. So this is not a very good approach, and many of you are saying this is deja vu, all over again. It's just a lot of apps and data sources being built in silos, lots of different standards. And so, what can we learn from the EHR world? Can we apply what we've learned from the EHR? Of course we can. I would say, though, that there are differences in mHealth data and EHR data that I think we should keep in mind from the get-go and not just apply EHR data approaches, without modification to the mHealth world. So these are some distinctions that I see that in the target user for mHealth, it's patients and clinicians. EHR, really mostly focus on clinicians and administrators. You can see that the perspective is different, that the location of where the data is collected is different. Data features in mHealth is highly variable, it's noisy, it's often very poorly validated at the moment, and most importantly, it's evolving. I don't think we really know what are the data features we really want to capture. We don't know what the valuable digital biomarkers are, and of course, lots of different sensors are coming online. EHR, in contrast, a stable set of data, reasonably well understood. In mHealth, the data sources come from many different companies. They often come from the consumer space. And in contrast to EHR, where there are dominant EHR companies, there's a lot of control by large healthcare organizations. And so it's just sort of the political economy almost of how data is controlled. It's very different in the mHealth space compared to the EHR space. For data exchange for mHealth, the data exchange is often at a very, very atomic level. It is to support real-time analytics for very personal use, whereas for EHR in general, it's more for batch data exchange and it's really for care coordination, often at the level, of course, of a document or a patient. In mHealth, there's a lot of consideration about technical constraints also, the power consumption, you don't want to keep charging your phone all the time, and then data usage rates, of course, and in EHR, the technical constraints are just less. So taking these differences in mind, we felt that there was a need for a dedicated standards project in mobile health. Open mHealth is a nonprofit company that I founded about 4 years ago now, and its objective is to build free and open source code that makes it easy for developers to standardize, integrate, store, and share, process, and visualize digital health data. So let me go through what we do in Open mHealth, and the approach is not going to be new to probably any of you on the call. The first is to create a common language, including schemas and an API, and then importantly to also provide free and open source tools to validate that data, to pull it in and move it around and process and visualize it. So let me start off just first with talking about the way that we think about schemas in Open mHealth. So schema structures data and follows design principles, which I'll briefly go over in the next couple of slides. Each data point, each Open mHealth data point includes a header, a body, and it includes annotations to standard vocabularies that we all know and love. And that's to help bridge integration with the EHR, for example. And we do make reference to the vocabulary codes using BioPortal, as you can see here. So the design principles, again, taking from experience, that we've all had in EHRs, and also, FHIR is also another approach that, has goals that are based on things that we've learned about for years and years of using and designing standards. So the design goes for Open mHealth that we've explicitly identified, having representations that are not too strict and not too loose. Because mHealth, the value of mHealth is that data is collected far and wide and shared far and wide, it's really important that the semantics, that the meaning be very clear, and that the context of that meaning be very clear wherever it goes. And then thirdly, to support EHR integration. So not too strict and not too loose. We know that templates that are very strict and very clear are very useful, but they're hard to use. Loose templates are, easy to use, but may yield clinically meaningless data. And we certainly don't want that. So what we want to do is to enable but not require descriptions that are as complete as possible for the major use cases that we might imagine. So as an example here, blood glucose, and remember this is blood glucose from the mHealth perspective and not from the EHR perspective. We certainly require units for a blood glucose number, but it's optional to specify the temporal relationship to meals or to sleep, for example. Integrity constraints, we enforce only the most critical ones, that you have to have a unit of measurement. Cardinality, for example, a blood pressure only has one systolic and one diastolic reading. There are loads and loads of constraints we don't enforce in the schema, but assume that it can be enforced programmatically. So that end dates come after starting dates, or a body weight can be more, can't be 3,000 kilograms. That's something that one can enforce programmatically and not in the schema so that we don't overload it. So it's really a case of striking a balance, not too much and not too little. We are mindful that a lot of the people developing the space do not have a clinical background, so we want to make it very as clear as possible for people to easily use these and at the end still have clinical value. So let me give an example of an instance of a measurement schema. Here we're trying to express the concept of average AM fasting blood glucose over a 4-month period. This is a typical kind of piece of data that you would collect in mHealth, and we want to be able to capture it, preserve the clinical meaning and the context, knowing that this particular instance could go far and wide. So here we start off with the average AM fasting glucose. So we have a way of saying, is this data point an average number? Is it the maximum number over a certain amount of time, minimum, and so forth? So this is average. This is AM. It's a relationship to sleep. It's on waking, and it's a fasting. Here we need to be thinking about people who who are night workers, for example, who may not always be sleeping at night. Of course, we have the value itself, and then we're able to state the effective time frame that this is a specific 4-month period. So this piece of data is clearly stated and is contextual and can be shared widely with maintenance of the meaning and the context. Each data payload also has metadata. It's described in a header. The header includes the data point creation and ID, the schema ID. So previously it was the schema for the blood glucose. And then, of course, we do need some information on provenance, the name of the source or device or app, when that data was collected by the source, and whether the data was reported, of course, more error there, or it was directly sensed. So an example of a header instance only to show that this is woefully inadequate. Provenance is a huge issue. I think we've been talking about it across the BD2K. We are MD2K specifically working with Zach Ives, who's PI of one of the 3 BD2K provenance projects, the Approximating and Reasoning About Data Provenance Project. We actually put in an NSF proposal to really dive deep into how we would represent and track provenance of data, mobile data at an atomic level, both in terms of its acquisition, in terms of its sharing provenance, and also data quality. That's critical to really using this data appropriately. So lots of ongoing work that needs to be done there. Let me touch a bit on EMA schemas, ecological momentary assessments. It's a collection of methods which basically prompt users in real time to report on their symptoms, their pain, where they are, and so forth. And the benefit of this is that you're obviously collecting data close in time to experience, so you minimize recall bias, and it's in the participant's natural environment, again, taking advantage of mobile devices being 24/7 and anywhere, everywhere. So it's a powerful method, particularly in behavioral research. I think we could probably use more of that in clinical research as well. Here's an example from a study, a project called eMocha. So it's just an example where there are questionnaires, there are different questionnaires. Each questionnaire is composed of different questions, and a question has a bunch of options to select from. Probably very familiar to you. This is similar to surveys that we're familiar from the clinical side too, like a PHQ-9, for example. And the question is, okay, so if we use mobile devices and we capture a lot of EMAs, and we want to integrate it, we want to learn across these, how do we do that? If it's just sort of described in a way that's not standardized, we're not going to be able to aggregate on information, which is very valuable. As a primary care clinician, I think self-report data is, as important as the physiologic data that we capture from sensors, for example. And so we do want to think about how in the ecosystem we want to standardize this data so that we can, integrate it and mine sort of additive data across these. So that's what we've done, driven by work in the BD2K project. And the approach we're taking is to model surveys or EMAs as an array of one or more survey items, plus a set of properties called delivery details that I'll explain in a bit. That each survey item is made up of a question and one or more answers. That each question is a text string or an optional label. And then the answers themselves can be objects, numbers, strings, or booleans, can be categorical, they can be a unit value like a weight or something like that. And this is work that Simona Carini has done a tremendous amount of work on in BD2K. So let me step through and just give an example of how this all works. This is an example of an instance, so this is a value from a questionnaire that asks about smoking urge. This is the label, SU urge. Here you get the text so you know exactly what the user was prompted. This is what they saw. And of course this is important because if you're getting this piece of data, you want to know what the person actually saw, what the actual prompt was, because there may be a lot of biases in how the question was phrased. Here, the person had answered no with 3 exclamation marks. That did not have an temptation to smoke. We have here when the question was asked to the user and when the question was answered by the user. There may be a delay, and that may be important in some situations. In the BD2K project, it is. And they give the block hours, the hour blocks where they took 1 or more puffs today. And here under delivery details, we see when the entire questionnaire of these 2 questions was begun to be asked to the user, and then the end date, and then it was successful because both questions were answered. Okay, so a lot of information packed in here, which is important for understanding the answers and the context of the answers, and then also for the project to sort of debug exactly when they got the survey and did they answer it and so forth. The way this is structured, of course, that the answers come from a standard set here. This is ones from again from our smoking project in BD2K, varying from no with 3 exclamation marks to yes with 3 exclamation marks. I really, really did want to smoke, and then constraints, and of course 1 out of these. So that's a general approach to being able to model many different kinds of questionnaires or EMAs. And of course, you can also tag a SNOMED code to a phenomena that you're trying to collect. These are the summary of the kinds of schemas that we're working on. Some of these are quite worked out, and they're now in the Open mHealth library on our website. Some of them are still under development, like EMAs. It still need testing. Geolocation, we're quite far along and almost ready to release that to the community. So a set of schemas that cover a broad range of data types in mobile health in general. Let me talk about the API and the tooling to actually use these schemas. So our approach, again, probably not new to any of you here, is to build out a data point API that exchanges JSON. It's all RESTful exchange. It's OAuth 2. The idea being that anyone can take this tooling and provide an Open mHealth API endpoint, and the Open mHealth ecosystem grows as people have these endpoints and can share data in a standard format that is quite declarative. The way to use this API, providers can either implement their own system, right, to take the whole thing and slap it in front of their own data store like MD2K is using, and I'll describe that in a bit, and run an open source storage component in addition. So in MD2K, I'll just step through kind of our data approach here and how Open mHealth fits in, and then step through what some of these specific Open mHealth tooling that we're using in MD2K. I would say it's been a great partnership, that MD2K is a real solid use case, of course, for developing our tools. We've also benefited from Open mHealth having thought a lot about these tools and have worked with people from across the ecosystem, commercial entities and healthcare entities, to really refine what some of the tools are and what the needs are. So here on the left side, we see we've got commercial apps and sensors, like, for example, MS Band is one that we're using. There are MD2K specific sensors like the AutoSense chest strap that we're using in our smoking cessation studies. The data comes in several different ways. Raw data goes to what we call the mCerebrum platform, which is a real-time computational platform that is on the phone. Right now, it's only Android, and so we're not really not doing HealthKit at the moment. There's also data that's going to come in directly from third-party sensors into their cloud. So, for example, the MS Band, in addition to getting data right off the band into the phone, we're also grabbing data from the Microsoft Band from their cloud. And there we want to collect data off the cloud using Open mHealth shim APIs and a tool that we call Shimmer, which I'll discuss more in a little bit, that takes data from these third-party clouds and outputs it in the Open mHealth format. So the data comes into the MD2K cloud environment. All the analytics are run there. DPU stands for data processing units, DBUs for data visualization units. The idea being that once you have data represented in a standard form, then of course you can build processing and visualization modules on top of that standardized data that can be reused. To share data, and for MD2K, two data sharing objectives of ours. One is reuse of the entire platform. We're going to be offering that as a service, direct use of the MD2K platform, or people can actually bundle up the whole platform and install it as a local instance, a local MD2K instance, and then the Open mHealth and DPUs and DBUs would come along with that. Today, I think we'll be talking more about the data sharing component, which is MD2K offering an Open mHealth data point API. And there it will be supporting collaborative projects such as the smoking cessation collaborative project that we have going with the Enigma Center, and also the Count Everything project that I've mentioned before, that we would expose mobile health data from MD2K via the Open mHealth data endpoint. The Picture Center does that similarly with EHR data, and then the Santa Cruz Center does that similarly with Global Alliance API, so a very similar approach. So let me step through now and sort of go a little bit deeper into the orange squares here. First is to store data. So here, MD2K is storing data in our own cloud environment, so we're not using the Open mHealth data storage, but the Open mHealth does have open source tools for storing data. It's an application that implements a data point API. It comes with it. You can see here written in Java, keeps data in MongoDB, runs a Docker. So very standard technology that people can just pick up and use. And that's certainly on our GitHub website, on our GitHub. Integrating data is very important. And here we have a tool called Shimmer that integrates with existing APIs from Fitbit, Runkeeper, WiThings. We have a whole list, and the list is ever expanding. Shimmer is a tool that you can download. I'm going to share the slides. You can just click that in there. And so, again, it pulls out data in Open mHealth format. We do have a tool that integrates with HealthKit. It's not something that we're using in MD2K at the moment. Many of you will know that HealthKit does not offer a web API for their data, so there's no API to shim to. But we do want to have a way of serializing the data out of the HealthKit data store and serializing that out again into Open mHealth format. So we have a tool called Granola that you can drop into an existing iOS app here so that you can take the data and then serialize it out in Open mHealth and send it off to your own cloud. And there are a number of people using that in our broader community, but not within MD2K. So that's Shimmer up here. Once you get the data in, of course, you want to process it. We are extracting logic that we need to be reusing. So, for example, minutes of moderate activity, medication adherence, those are processing modules that have been developed by MD2K, are on the, not by MD2K, by Open mHealth, and it's on the Open mHealth library. Within MD2K, we're developing processing modules like stress detection, detecting the smoking episode. So this is really getting into those digital biomarkers, right, that people can then reuse. And we're building processing API so that then you can call, a resource and be able to access this logic in a reusable fashion, or indeed to download and, use it yourself and plug it into your own processing pipeline. In addition, of course, we want to visualize data. We have a set of visualization modules as well for the kinds of data we're collecting: blood pressure, weight, heart rate, and so forth. And those are free and open on the Open mHealth website as well. We will be reusing some of these within MD2K, and whatever else we build, we will contribute back to the wider community as well, of course. So that's these two orange boxes in here. The technology is all open source. It's on GitHub. It's written using mainstream languages. We found that to be very important. The developer community, the startup world, for example, has had, it's been very easy for them to just pick this up and run with it. And that's very important. So our community, the Open mHealth community, is it's growing. 6,000 people of various levels of involvement within our community. We have meetups all over the world. We now have 75 release schemas, close to 100 total if we add in the ones that are close to being released. Over 2,000 downloads so forth since so far. The platform is being used at Kaiser, Stanford in a pilot project, the University of Toronto is using the platform and our visualization modules. We do have professional services available. The implementation of Open mHealth and MD2K being integrated into the platform and the tooling is to come sometime later this year. So a community that is growing, certainly, the more the better, and trying to get that virtual cycle going of people contributing, and the more that we contribute, the more value there is, of course. And the main reason why we made this as a open source community. So I know many of you are thinking about what about integration with EHR. That's a critical issue, of course. We have two approaches. One is that we have worked with a company called Catalyze, who built mappers from HL7 V2 into Open mHealth. They have open sourced this. It's a package called Pulse that you can get at this link. Again, it takes HL7 V2 data and spits out Open mHealth data in an Open mHealth compliant form. Now, there's a lot of interest in FHIR, of course, so we might look at Open mHealth as sort of addressing this column, and FHIR is addressing this column in the table we've seen before. And I think that a case can be made that the use cases, the dominant use cases for FHIR and the dominant use case for Open mHealth are different. They overlap, but they are different, and that overlap needs to be explored more. I don't think that one is a subset of the other. The approach that we're taking technically is very similar between the two, as you can see here. And, FHIR addressing resources that cover, the 80-20 rule for EHR needs, and we're doing the 80-20s really for the mHealth needs. One might, this is sort of a general view of it, that there is overlap between the way Open mHealth represents things and FHIR resources around these data elements. These are some other concerns that are overlapping. These are things that will overlap in the future as we start working on them. There is a lot that does not overlap, but this intersection of the Venn diagrams does need to be worked on and to show, you know, where the overlaps are and where things are different and why they're different and do they really need to be different. It's something that we're just starting working on. I think hope to report on that in the future. But just as an example of what this might, of how there's a difference between the way Open mHealth and FHIR think about things. So for example, in medication adherence and medication modeling, the Open mHealth way models the medication, of course, the prescription, the dispensing from the pharmacy. Do I actually have that pill bottle at my home? Very important that there be a customized schedule for the patient. Some people wake up really early, some people have shift work. You know, if it's a daily drug, do I take it at 8 a.m.? Do I take it at 4 p.m.? If it's a TID drug 3 times a day, what are the times that I take it? Okay, we need to know that to know whether a dose was actually taken. If you're supposed to take a drug at a pill at 8 a.m. and one at 1 p.m. and you say you took a drug at 10 a.m., you know, which one is that? Is that the morning pill or the afternoon pill? The reason the dose is not taken, and then of course calculating an adherence, a medication adherence. And so the thinking here is that there's a prescription which is mapped to an individualized patient schedule. There needs to be an acceptable window of when you have quote unquote taken that dose. So if you're taking a drug like levothyroxine, it doesn't really matter, you know, when in the day you take it because it has a very long half-life and a long, you know, influence period. Whereas if it's an antibiotic, for example, you know, and it's a 4 times a day antibiotic, you want to know, you know, did you take the drug when you were supposed to? And then calculating doses taken and an adherence, which is very specific to that individual. You can contrast that to FHIR, where, you know, medication order dispensing, the things we're all very familiar with, but does not have the level of detail and temporal resolution that really allows one to generate medication adherence at an individual patient level, which is what you would expect when you're getting medication adherence, you know, let's say from an app. This modeling and thinking we developed in Open mHealth with a working group that involved companies that are developing medication adherence apps. We also had a pharmacist on the team, and we also had people who were specialists in medication adherence. So again, it's an approach that brings in developers and clinicians and researchers to really look at the data and say, you know, what do we really need to represent? What is the context that we need, and how do we represent that cleanly? So in summary, and then we can take questions and have a discussion. mHealth data is very rich, it's very varied. I would say that it's different from EHR data, different enough that it's worth thinking about how to represent it in ways that are, you know, not just using FHIR, for example. And that's something I think as a community can work through how those differences should manifest itself in our technical approach. Open mHealth is the only mHealth-focused data standard out there right now. Open schemas and open APIs and open source tooling. 4 important things like integration, storage, processing, and visualization with a growing community of both developers and users. It's been a really great partnership with MD2K and with the Count Everything BD2K project, being, you know, forced to develop the tooling for real use cases and real needs is very exciting. So some of the current work, testing the EMAs, provenance is a huge topic that we hope to get further in starting this year. We're developing the query and processing API, mostly with the Count Everything project. That's a really good forcing function for us. And also looking for more opportunities to explore a mapping between Open mHealth and FHIR, or with other representations for EHR data. We are actually, I would mention, we also have a project with Santa Cruz that is specifically looking at the sharing of physical activity data from sensors and also genomic data. That's another administrative supplement project that we have going, and that explores mapping between mHealth and genomic data. So I'll stop there. I would love to take comments and have a discussion at this point, so thank you for your attention.
Thank you, Dr. Sim. That was certainly a lot of information and very informative. I really enjoyed that. Does anybody have any questions or comments for Dr. Sim? One of the questions that I had was, you mentioned several sensors that are available commercially. Have you tried to interact with all of these companies, and how has that gone? I mean, there's obviously a lot of terms that they're using. Are they all measuring it the same way? We know that, it's probably not the case. So I guess my question is, do you see a drive in the future for the companies and the standards world to integrate and work together, try to define some of these terminologies?
Yeah, so that's been the objective of Open mHealth from the get-go. It's an independent, neutral, open community for all sectors to come together, the researchers, the engineers, the clinicians, the device makers, the business people from the device companies, and that has happened. A particular initiative that we've just started that addresses your specific point is an exciting project that we have with the Stanford Mobilize Center, Joy Koo and Scott Delp. And what we did there was we identified that physical activity and mobility monitoring is really sort of the more mature part of the sensor market, right, on the consumer side at least. And yet these devices are not being used in clinical care nearly as much as they could be, and they're not being used in research nearly as much as they could be. But it's also clear that the companies are starting to want to do that. And in order to move into the clinical market and the research market, they do need to, validate, to show the accuracy of their sensors. And there's a problem there because often they don't really know what clinicians want, right? And clinicians and researchers on our end don't really know what the device makers can offer. So in March, the BD2K Center and the Stanford Mobilize Center convened an invitation-only meeting, and we brought in over 20 companies that are all the leading companies in physical activity and mobility monitoring. So MC10 was one of them, but we had Nike, Google, Apple, Basis, Misfit, Lumio, Azumio, Fitbit, basically all the ones that you can think of. And it was a really, really interesting meeting because everybody saw the need to be more on the same page in terms of what data we need to represent, how we need to represent, and more importantly, how do we validate. So the outcome of that meeting is that I think we're going to have a consortium where we will define some clinically useful measures. So for example, not just steps, because it's clinically not all that useful, but maybe measures of gait, measures of balance, measures of fall risk perhaps, because we had clinicians from neurology, Parkinson's and MS, multiple sclerosis. We had people from the behavioral sciences. We had people from depression. We had people from, the elderly. What are the measures that we think are clinically important? How do we validate them? So set some validation targets and then work with some companies that have already offered to sort of be the test case to share their data openly. I'm hoping that we would use the BD2K platform to then have the community openly validate against community-defined validation targets. And then that starts to close the loop between what's important, what's useful, bring in the companies, and then have the technology infrastructure for doing sort of a large-scale validation of measures that really matter. So kind of a long answer there, but very excited about that collaboration and another example of how I think the BD2K Consortium has really brought together groups that that can work together in ways that we couldn't have before.
Got it. Thank you. So I guess there's going to be some movement to define some of the terminology so that everybody is working with the same definitions.
Yes. So we've proposed a bunch on the Open mHealth for things like blood pressure and blood glucose. Some of ours are being used by, some large companies you know of. I don't think it's quite public yet. But there are a lot of measures that we need as a community to define. So for things like gait, for example, and so those efforts are underway. And we'd love to have more participation. Some of the centers in the BD2K Consortium who are experts in particular domains to work with us. We're working with, for example, the PRISM group, which is a pediatric asthma group out of UCLA, for example. So we're working with them to define measures for respiratory medicine. So, love to have more collaboration.
Got it. Thank you. Thank you, Dr. Sim. Are there any other comments or questions?
I had a question regarding mobile sensors, operating systems that are currently being used, and if over time these operating systems will evolve, how the applications and the data that is produced, although we are using open source software and format, will interact with latter generation operating systems for mobile devices. So
what do you mean by the mobile operating systems? Do you have any in mind that you?
Currently, they're being, depending on the sensors that you use, each of them has certain operating systems that are being used to collect data, either digitally or real-time analog. So I'm just trying to think how are we going to be able to ensure that the data that is produced by a certain set of OSs currently will be able to read down the road over time?
Yeah, so Open mHealth is focused in some sense more distally. We're focused on data that has already been uploaded into a cloud. That's where we're starting because that's the easier part of it. And then to map that data to, to the standard Open mHealth representation. We do have discussions with some vendors, some sensors to directly output their data into Open mHealth format, in their own cloud. That's a process that's ongoing. We do not focus on sort of upstream from that, the collection of data on the device itself and the operating systems they use and internal representations within a sensor. We're not focusing at that step. It's still an open question if we do need to and how we would do that. We're working that through with the MD2K project because the mCerebrum platform is a phone-based platform. It does collect data directly from sensors. It does onboard calculations, computation. It does real-time prompting and real-time data collection. And we're still working through right now what is the role of Open mHealth at that level. So it's not clear yet, I would say.
Okay, thank you.
Are there any other questions?
Dr. Sim, this is Rima Glenkhire from Memorial Sloan Kettering. Great presentation, thank you. I have a couple of questions about mapping to standards. At which level in this process you map to standard terminologies?
Yes. We map to the terminologies at the level of the schema. So let me go back to let's see. This is an instance of a blood glucose reading. And in this instance, there is a header, like in here. And the header, and this one is for physical activity, but imagine it was for blood glucose. There is, and it's just not shown in here, there is a schema ID, and that schema is annotated to the appropriate SNOMED or LOINC or whatever term. So you can link back to it, but it's at the header, so that you don't carry that information, you don't carry that mapping to a SNOMED code, for example, within every single instance, but it's there if you can unpack it.
I see. And you don't have mappings for everything, right? And the
Yes.
next question is, what percentage approximately of the data elements that you're collecting now are mapped to standards?
Simona, I think you're on the call. Do you want to answer that? I think Simona's on here, or maybe not. We do, I think all our schema IDs are mapped. The value sets are not mapped, and it's partly, you know, there's just a lot of overhead to mapping everything. And, you know, we're waiting for really good use cases to drive the decision, you know, what the 80-20 split is. We want to be pragmatic. We don't want to overload everything. So, you know, we're really right now mapping at the level of the schema, and the vast majority of those are mapped to a standardized control term.
Thank you. And the last question about reconciliation and mapping of different representation of similar things like activity that you showed in one of your first initial slides. How do you do that? Do you find a common denominator? Do you do any transformations on the way to the mapping to a standard?
So, for example, like the METs, the calculation of METs, is that what you?
For example, activity. You showed several ways of measuring activity.
Mm-hmm. Yeah. So we do have for the data sources that we get data out of into Open mHealth format, and then we have a processing module that figures out this is information from, you know, Google Fit, and this is the way that we, you know, calculate METs from Google Fit data. And so there is a processing module, which is, you know, we've open source and people can use that. So yeah, there's a lot of processing involved. And we want to be very explicit about the processing that happens. It's part of the problem with a lot of the mHealth stuff is you may get a derived value, but you don't know what went into it and what was the algorithm. It's you know, there are many different algorithms that go into calculating METs, for example, based on your weight and your age and so forth. That's part of the work of provenance that we need to think through more clearly, is what's a scalable way to attach that provenance information to atomic data, which could be very, very high volume. So what's an efficient way to do that? And that's work we're doing with Back Eyes and his center.
But you publish your algorithms, right? They're available.
Yes. So you can go look on the GitHub site, and it should be self-documenting on there. Yes.
Thank you very much.
Thank you. That's all the time we have for our webinar today. On behalf of Dr. Sim and the team at the BD2K Standards Coordinating Center, I want to thank you all for joining us and for your participation in this presentation. Have a great afternoon, everyone.
Okay, thank you very much, everyone. Thanks, Rhonda.